What's up, guys? Welcome back to Vanover Customs, and we got a nice little video for you today. We had a customer come in off the street and he has a broken part. We need to make a replacement. Let me bring you in closer and show you how we're going to knock out this rush job. Here's a look at the part that we're going to be making. The customer brought this to me. It's from a Cummins diesel engine. There is a pulley, this part, and then a rubber harmonic balancer, and they're all sandwiched together. This part was originally made out of cast aluminum, and the diesel mechanics broke it during the removal process. Because of that, we're going to be making the new one out of steel because he told me it will be likely removed again, and so we want to add a little bit of durability there. We went ahead and made a drawing. It's probably not necessary, but I want to improve my drawing skills, so I've been doing drawings for a lot of these small and odd jobs. So we just have some notes on here and some dimensions. Everything is in SAE, which is really nice. So everything is standard imperial. We do have a nice piece of 4-inch that we're going to be making this out of. So the next step is to get that over to the hide mech and get that sawed off, and then we can start machining. Well, looks like it's time for a new blade. That other blade was in rough shape, but I think it finally gave up the ghost. All right, after a new blade replacement and clean of the machine and replacement of the coolant, let's get back to cutting. I'm already going to get a few questions on why we flipped that around. The main reason is when you're doing heavy cuts on a part, it can have a tendency to migrate. By going ahead and turning a shoulder and flipping the part, we let the shoulder rest on the jaws so we can come in here and take some really healthy cuts and not have to worry about the part migrating. Another benefit of doing that is we have a nice machine surface to clamp on, and we don't have to worry about our measurements changing if the part were to shift and we didn't notice it. So with that being said, we're just going to jump straight into doing some heavy machining and taking some healthy cuts. Grabbing a measurement here on the OD. Four and 7/1000ths, that's 7/1000ths over. We're gonna leave it large in case we gotta grip it on the outside with the jaws, so I can come in there and clean up the jaw marks. It was originally cast, so that measurement's not crucial, so we're gonna roll with it. Over at the lathe here for the last operation, we got to drill 6 holes equidistant at a bolt pattern of 2 3/4 for the diameter. Now there's several ways you can do this. You can do this with the bolt hole function on your DRO. You can do it in a rotary table. You can do it on a dividing head. There's several different ways, but ultimately I want to do it as accurately as I can, and on this setup I think this is the best way to achieve that result. Now I've went ahead and already found the center of this using a coaxial indicator, and then I just double checked with a traditional edge finder and my measurements were the same. So we're all set up and good to go there. We're going to come in and spot all 6 holes, then we'll drill for a small drill bit for the web, then we'll come back and hit it with a 5/8 drill, and after that we'll bore it or drill it to final size, and then we should be good to go. Rotate 60 degrees. We're going to clean up these rough holes with this miniature boring bar. I've already set it up and measured the first hole. The clearance here doesn't really matter. I'm making it off the old one and it's cast, but I am trying to get it close to my drawing. So this hole is within 1/1000. So we're going to go ahead and just go around and bore all of these so that they're nice and round, they look good, and that they're matching the drawing. This carbide could probably stand to be sharpened, but it'll work just fine for this job. For the last operation, we're going to come in here and just kiss this with a chamfer. I don't need anything crazy, I'm just trying to break the edge, so let's go ahead and get it done. Well guys, we got this part done and it looks really, really nice. I think measurement wise, we're looking good too, but we're going to talk more about that in a minute. And obviously for the application, this part is more than sufficient. Again, the old part was cast, so between draft angle and castings, there wasn't really a lot of necessity for accuracy. But to kind of test myself and see where we landed, I've got my beautiful mid-tutorial micrometers out here, and we are going to put my feet to the fire and see where I made mistakes and where we succeeded as far as that we get our measurements as close to the drawing as possible. So let's jump right into that. All right, before we measure these, I just want to reiterate. We're doing this mostly for fun and for learning, right? I don't claim to be the world's best machinist, and I am still learning. And again, for this application, it is perfectly acceptable. And in that regard, we probably did a perfect job. However, I do want to try to treat this project as a tool to get better. And so I try to hit pretty much any and all dimensions I can as best as I can, so that way when the time does come where something needs to be plus or minus, a thousandth or whatever it is, I have the skills down. So with that being said, let's jump in here and just kind of go through the measurements and see where we landed. I'm going to use this camera battery here to just kind of prop this up here. All right, so the first one is the OD. Again, not a critical one, but we're going to check. It was supposed to be 4 inches. There was no tolerance given because I'm the one making the tolerance. So let's see how he landed. I'm just going to read it out because it's upside down. Come on up there, buddy. All right, we got 4.00165. So that means that we are 1,006 oversized. So if that was a plus or minus 2,000ths, we'd be in spec. Plus or minus 1, we'd be out of spec. Still really good. All right, so that's the OD. All right, next, let's do this dimension here, all right? So it looks like that's going to be 1.375. So we'll take our 1 to 2 mic, see where we landed on that. All right, 1.3737. So we are 1.3 thousandths or 1,003 undersized. Again, plus or minus 2,000ths, that would be a pass. Plus or minus 1, that'd be a failure. Pretty good in my opinion. All right, let's get the depth here. So we're looking at 1/2 inch. I don't remember being very particular on this one, but we'll see. Make sure we're cleaned off here. Yep, this one's worse. All right, we have 0.50305. So that's 3 thousandths. We'll just call it 3 thousandths because it's 30. So we're 3 thousandths oversized. Again, plus or minus 1 thousandths, failure. Plus or minus 2 thousandths, failure. Plus or minus 5, pass. Not too bad. The next thing is this depth here. All right, I believe that depth needed to be, let's see, 225. Let me get a depth mic. All right, and again, I'm showing you guys this because this is reality, right? I like to show reality. All right, we got the depth mic here. We're looking for 225. All right, so we're looking at 222. And let me just read how many tenths that is. And it looks like 1/10. So that means we are 2.9, so 2 thousandths and 9 tenths undersize on that depth. So that means if it was a plus minus 5 thousandths success, 1 or 2 thousandths failure. All right, that's that measurement. The inner bore is not even specified in the drawing, so I just ran a 13/16 drill through it, so we're not even going to mic that. And the same thing with these holes. Actually, you know what? It is spec'd 0.695. So give me a second. We'll get a micrometer stand and a snap gauge. Now, I will say on this hole, or holes, they are clearance holes for bolts. So the bolt is 5/8 and they're already oversized. So even in the real world, the tolerance on this wouldn't matter too much given the application, but let's see how we did. I know I wasn't that concerned with it. I'm fairly positive I wasn't. But we'll just see how we landed. If I can get a good reading here. Always want to rock these when you're, there we go. All right, let's see how we landed. I'm going to take 2 or 3 of them, synthesize them. All right, we're looking at 675. What did we need? 695. So we're 20 thousandths under. That sounds right. Actually, wait a second, my drawing's wrong. I measured these and these were 675. All right, we got a caliper here. Again, this is cast, so. All right, I'm getting 660 on that hole, 663 on that one. I thought I measured one at 675. 662. Oh, there we go. 670. You can't see it. It's upside down. So 670. I could be lying, but yeah, 668. Okay, so let's just say 670. All right. So that would put us at about 5 thousandths away. Let's just do another hole here. That one's showing up at 6775. So that's about 2 thousandths oversized from what we just read. Let me just take another measurement in that hole, make sure it's not an error reading. And I'm getting 4/10 over that last measurement. Snap gauges do have some, oh no, that wasn't 4/10, that was 4, just double check. No, that's 4/10. Okay, so 4/10 over the last measurement. Okay, so we're at let's just call it 679, we'll call it. And when we measured these, we're getting 670 down to 662. So that's 9 thousandths on the best case, maybe 15 on the worst case. And I know that I didn't really pay much attention there. I'm fine with that. I'm totally fine with that. It's a clearance hole for a bolt, and we gave it a little bit more clearance. Won't be a problem. Well, I hope you guys enjoyed kind of measuring this. I typically don't do this, but I just wanted to show you where we ended up and what reality is when I make a part. Again, there's parts that are more precise, parts that are less precise, but I'm getting better, and I think we did a good job overall given the application, but let me know what you think in the comments. Well guys, that's pretty much it. We got the part done, and we got it done ahead of schedule, which the customer is super happy about. We're gonna get him back on the road with that engine, and we're gonna move on to our next projects. If you guys have any comments, questions, post them down below, and we'll see you in the next one.